1 minute. Okay. Time to do something. Good time to do something. For example, move the healing. Silence. prepared a demo here. Here. This part, I'll draw schematic. I have DC generator, capacitor, this is smaller capacitor, no, so I'm starting drawing it incorrect. Coil and one small capacitor, and here I have spark gap. One more coil. These two coils are coupled. Capacitance here. Ball. Where is my yellow chart? Signal from here is my yellow line. Yeah, yellow line. You can see it's one more. Decaying oscillations, frequency approximately 1.7 megahertz. Yeah. This ball, set of coils in the glass vial. Discharge part. This one is voltage divider for my scope. All together, if you recognize it, it's a Tesla resonant transformer. I have a tiny model of Tesla, famous Tesla tower. How it works? Here I have DC source, through this resistor and coil capacitor charges. When capacitor voltage reaches breakpoint, spark gap breaks through and forms a resonant contour where decaying oscillations occur. Since it coupled with secondary contour, here also induce oscillations, and they are quite high voltage. For understanding magnitude, it shows 5 volts, but this divider is 40 megaohm to 10 kilo ohm. It's divided 4,000 times. So this 5 volts is actually 20 kilovolts. Okay, that's not all. In my demo, here, this part is my Tesla transmitter. On the opposite side, what do I have at opposite side? Coil, adjustable capacitor, small antenna, and here I'm taking second signal. let's see. Well, yeah, here it is. Do you see what I see? I see what energy from primary system, energized by my muscular force, is transmitted or transferred to secondary system. There is no wires here. Electromagnetic field can, how to say, reach over space. Or electromagnetic waves propagate. If electromagnetic waves are propagating, it's immediately a question. Can I use this effect to transfer what? Information. To send some info from point A to point B. I can use presence of signal itself. It will be keywork or telegraph. But would be much better to transfer voice, voice, or better, image. So how can I use this magnetic wave propagation to transfer some information? Here frequency 1.7 megahertz. Problem, low frequencies, propagation of low frequencies is a heavy task. And space, how to say, space, frequency space available for transfer, it's giant, but it's on, not on voice frequency, not acoustic frequency, but on much higher frequencies. Okay, how can I pack some info inside a propagating wave? Good question, isn't it? Okay, let's start with idea. First, I need a carrier. Signal what will propagating signal what will act as an envelope or as I don't know, as some kind of horse to carry my information. It can be something like cosine omega 0 plus P0. Let's say harmonic signal what I can use as a carrier. And I have excellent signal what I'm looking ways to send it to my recipient, send it to my remote correspondent. What can I do? If I use magnitude, if this signal will be changed by the, in some connection by the law of the signal of my sender signal or modulated. This is called modulation. It's a process when carrier signal is changing in some way to carry information. This is information. I would like to pack it and send. So if I pack it within amplitude, it will be amplitude modulation. If I use frequency, it will be frequency modulation. If I use angle, it will be phase modulation. I can pick any parameter parameter of my carrier signal. Let's start with amplitude modulation. It's simpler and historical. First, real working system used. Okay, first use simple yes no binary with Morse alphabet. But they're modulating, again, they change amplitude by change 1 0 1 0. If we use this for transfer of sound, of voice, some oral information, magnitude will be subject. So, okay, I have info to send, cosine omega 0 time, carrier. This one, some kilohertz, here, hundred thousands of kilohertz, megahertz. Maybe. What will be my packet signal? Signal to send, this will go to antenna system to go away. Will be 1 plus m x cosine omega 0. Okay, there can be 0 time phase shift. Here, this m is a depth of modulation or modulation index. How deep I'm using my signal? It can be from 0 to 1. If it be over the 1, we will get something very distorted. Let's start from simple. From something very simple. Let's assume what my S is simple as cosine omega S. One harmonic signal. It's for simplicity. So transferable signal will be 1 plus m multiplied by s maximum multiplied by cosine of omega s multiplied by cosine omega 0 time. For simplicity, I assume 3 0. I need to open this. Be even. To make it more simple. I need to open this, but how can I open? I need to remember school trigonometry. Cosine alpha, cosine bet can be rewritten as 1/2 of cosine alpha plus bet plus cosine alpha minus beta. So my modulated signal can be rewritten as O max multiplied by cosine omega 0 time plus m divided by half multiplied by cosine not enough space, we'll continue here. Cosine of here should be omega 0 plus omega s time plus cosine of omega 0 minus omega s time. If I drew a spectral diagram of this beauty, appears what I should see something like this. Central at omega 0 carrier frequency, and to line this will be at frequency omega 0 plus omega signal, omega 0 minus omega s. The magnitudes are modulation index, 1/2 of modulation index. This is max. Omega. Appears not very effective. Information contained only here. Power of information part is something like m squared divided by 4. Effectiveness, top ideal in case of M1, effectiveness will be only 33%. Actual effectiveness is some 20%. It's not very effective. Actually, I need to some space. One moment, I will bring in demo signal. Signal. More space. I need more space. More space. Space. I need space. Object number one. Object number one. Okay. Here is nice harmonic signal with magnitude, with frequency 500 Hz. Yeah, 500 Hz. It comes from my big generator. Signal with magnitude 500 Hz. And what I'm willing to do with signal of 500 Hz. One second, I'll bring one more object. This one. special generator. Now this generator produces signal of with frequency 20 kilohertz. It will be my carrier signal. 20 kilohertz yellow my carrier, and 500 hertz signals to carrier. Here they are in scale. I'm changing depth of modulation. It's over 1. Now, where am I? 50%. Depth of my modulation is 50%. M, 1/2. Here, 20 kilohertz are modulated or subjected to 500 hertz. Let's try to get spectral composition. Here, central frequency 20 kilohertz, 20.5. Here, upper sideband, should be 0.4. I have shifted. This one, this line. Changing the depth of modulation. You see what carrier central frequency remains the same, but side frequencies were info. Now, let's take something more complex. More complex, what do we know? We are familiar with rectangular signal. Such signal has a composition as max sine omega t plus 1/3 sine 3 omega plus 1/5 sine 5 omega time, and so on. Okay, let's add 1/3 of the 5th harmonic. Here, I've added 3rd harmonic angle. signal with 1/3 of the third harmonic. And you see, carrier, base frequency of signal, third harmonic plus, third harmonic minus. Add fifth harmonic. Okay, here is my approximation to rectangular. Modulated signal, first harmonic, third, fifth. Minus base, minus third, minus fifth. On my frequency scale, omega 0, 1, 2, 3, plus omega s, plus triple omega s, plus 5 omega s, minus omega s, minus 3 omega s, minus 5 omega s. That's what we see. If signal you like to transfer has a spectrum, I don't know, like this, you will get omega 0 plus minus. This is called USB, upper sideband. This is called LSB, lower sideband. They are symmetrical, they carry information. Here at carrier, there is no information, actually it's a wasted energy. Both carrying the same information. So, to save energy, this can be rejected from signal. It will be balanced modulated signal. Only upper sideband can be transferred, or only lower sideband. SSB type of transmission. SSB types of transmission are used for communication, for commercial communication. Okay, how can I, one moment, how can I extract my information? Here, for example, is my information encoded or packed in such kind of signal, amplitude modulated signal. How can I get my information back? Simplest thing is to pass it through diode. There will be small problem. One moment, I'll try to show it. One moment. Where are you? And where is my... Oh, I see. is my little box with lot of signals. To suppress higher frequencies, usually small capacitance is added. Or small probe too big. Oh, okay. It will go from there. Here will be my ground. My small resistance box will act as a load. No, this is not right. Modulated signal. I run out of connectors. Because I took wrong. take a measure. 400 Hertz plus 1.5 kilohertz distortions. To avoid this distortion, different technique of